Alright, we are on our last one. Another one that was just sort of hand-drawn, so I'll just recreate it here. We have a force diagram below, well, on your sheet is probably below, and it's the following. You got an 18-degree ramp with the following forces. Fg of 3,000. You've got normal force acting up. We don't know it. Force of kinetic friction, FFK, of 1,200 newtons. We've got a tension force also pulling down the ramp. Alright, so first thing with any ramp is break Fg apart. Fg is broken into its x and y pieces. Fgx is, as always, Fg, the x part will be this one. So that's sine, Fg sine theta, and this one is Fg cosine theta. Our Fg is 3,000. Our angle is 18. Alright, so 3,000 times sine of 18 is 927.05. And 3,000 cosine 18 is 285.32. Okay, so we have a couple things. Well, first of all, on a ramp, the Fgy is always equal to our normal force. And we have to find, we have to find the normal force, we just did. Check. We have to find the mass. Well, the mass is relatively easy, it's just the weight over 9.8. So that's 3,000 over 9.8. Which is 306.12 kilograms. So that's all set. And we have to find mu k, which mu k is the force of kinetic friction over the normal force. So I can do that by taking the 1,200, which is our kinetic friction, divide by the normal force, which we just calculated was that doesn't make sense. Aha, that's why. 3,000 times cosine 18. 2853.2. 285. Move that decimal over. It's 2853.17. Who's calling me? Someone's calling me. Yeah, I'll get it later. It was Morgan. 2853.17 newtons. So, our normal force is that, 2853.17. The reason I just realized that something had to be wrong was because my normal force was going to be less than my my kinetic friction, which means my coefficient would have been greater than 1. We know that that's not supposed to happen. So that's what triggered something to check. I would have gone on without realizing that. So I went back and looked. So 1,200 over 2853 is 0.42. 0.42, and it's units. And the last thing we have to find is our tension force. We know that the acceleration is 0.3 meters per second squared down the ramp. So, we got to set up our good old Fnet equals MA equals force up the ramp, UTR, minus the force down the ramp, DTR. And solve this equation. So our mass, we just found it a little earlier, 306.12 times negative 0.3, negative because it's down the ramp, equals our force up the ramp is just the 1,200, minus, we have two forces acting down the ramp. We have the force of tension plus our FGX. FGX is what helps us down the ramp. So I'm going to put those combined into a parentheses. Our FGX is 927.05 plus, because these are the addition of all the stuff down the ramp, plus FT. This is the minus that takes care of the different directions. So 306.12 times 0.3 is negative 91.84 equals, I'm going to do 1200 minus 927.05 is 272, a positive number, 272.95. This minus carries through, minus the force of tension. I'm trying to solve for what the force of tension is. So I'm going to subtract the 272 from both sides. 0.95, and I get negative 364, bring it over here a little bit, negative 364.79 equals negative FT. Very easy to see that the force of tension equals 364.79 newtons, and because we already used this negative as the direction, we know that it is down the ramp because this negative already told us that it's down the ramp. We know that we need more force down the ramp than we have up the ramp. Up the ramp we had 1200, we already had 927 from gravity pulling it down, but we needed more to overcome exactly what that was. In fact, we needed 91 newtons more than the 1200 overall down the ramp in order to get it to accelerate. So there's our force of tension. So we were looking for the normal force. That's here. I noticed I had a mistake because it was a little too low. Found our mass, found our coefficient of friction. This is where I realized that my normal force was too low. It wasn't 285 because it would have given me 1200 over 285 would have given me 4.2, which just doesn't make sense. Too high. And then we did a couple steps to find our force of tension. One thing you should notice, though, is we're constantly using this equation. We're constantly using MA equals the forces up the ramp, down the ramp, minus down the ramp, or the forces right minus left, or the forces up minus down. You set them equal to MA and solve for one of the things. It might be the mass we have to solve for. It might be up the ramp. Doesn't matter. As long as you set up this equation, you'll know 3 of the 4. Or in this case, 4 of the 5, because we had 2 forces that were acting down the ramp. Alright, so hopefully that helps, and you can use this on your test. You can use it to study for the midterm, whatever the case may be. And we'll go from there. We'll pick it up on Monday. Have a good weekend, everybody.